Right, today's lesson is about looking for z-scores again. Um, and today we are looking at the right tail. So what do we mean by the right tail? So if I have my z-score here and I've got a line, we've talked about between the mean, and z. The right tail is looking at the area above z. So it's everything that's above z. Now there's no table for this result to work out that area. So what we have to do is use what we've got. What we do have a table for is we have a table for working out this area. So we should know that half the graph from here out to there is equal to 0.5. So if we can use the value from the table and we take that away from 0.5, we end up finding with the leftover area there. So that's what we mean by the right tail. So z value that's above the median and everything, the area above that. Now the good news for questions is not a lot changes. What changes slightly is how our diagrams look. So the reaction times of students is normally distributed. The mean of the reactions is 0.30 seconds and the standard deviation is 0.15 seconds. What is the probability that a randomly selected student's reaction time is greater than 0.339? So same steps as before. First thing, draw a picture. So get your bell curve up again. So what do we know? We know, first of all, that the mean is 0.3 from there. The next thing we know is that the standard deviation is equal to 0.15. What we are trying to work out is we're trying to work out the area that's greater than 0.339. So 0.339 is somewhere here. Again, doesn't have to be a perfect drawing as long as it helps with showing what you're trying to achieve. Now, because we're looking for greater than, we are looking for this area here. Sorry, x value. So first thing we need to do is convert those values into z values, which hopefully we're getting more comfortable with now, so that we should be able to change the mean into 0 and standard deviation equal to 1, call that z. The only thing we need to work out is what our value here is. So we can get our calculation up again. So z is going to be equal to, x in this case is 0.339. Take away the mean, which is 0.3, over 0.15, which equals 0.039 over 0.15. Let's try and do that quickly on the calculator. 0.039 gives us 0.26. 0.26. Right, so we now know what the z score is. So now look up the probability from your z table. Here is our z table again. Remember, first decimal place, second decimal place, third decimal place. So 0.26, so 0.2 and 0.26. So we are measuring all the way across to there. That gives us that the area In other words, this area is equal to 0.1026. So what we've found from the table is that the probability that our values are between 0, or Z values are between 0 and 0.26 is about 10%, or is 10%. However, that's not what the question's asking us. The question's asking us to find greater than our value. So what we need to do is change that. So the probability that Z is greater than 0.26 is going to be half of all the values in normal distribution. So what you have to do is you have to take away our 0.126. So 0.5 take away 0.1026, which gives us the answer 0.3974. Okay, so the probability that it's above that number is 39.74%. But remember that we haven't finished our question there. Is that we now need to write it in context. The probability that a student's reaction time is greater than 0.339 is 0.3974. So the key to that question is understanding that because we want to find the area greater than our value, we have to take that number away from 0.5. Let's have a look at another example. So for this one, the length of a great white shark is normally distributed with a mean of 10.5 meters long and a standard deviation of 0.5. What is the probability that a randomly selected shark is more than 10.96 meters? So what I want you to do is have a go. I'm going to pause the video, have a go at seeing if you can answer the question. If you want, go back to the previous question, have a look at all the steps, but the steps are exactly the same. I want you to draw the picture. I need you to calculate the Z score. I need you to get it from the table. I need you to then answer the question in context. So pause the video now. Okay, hopefully you had a go at that. Let's take a look at the answers. So the first step, we need to draw our picture. There it is. There's our graph there. First thing we've got is the mean is 10.5. The x value, or the value we're trying to find out or use, is 10.96, and standard deviation is 0.5. So step 2 is we need to calculate the Z score, and here's our formula again. So using that calculation, we end up with that Z equal to 0.92 of the standard deviation. So we can look at our table in step 3. So first of all, 0.9 and 0.2, so they're 2 decimal points. So first decimal point is 0.9, second decimal point is the 2. Then find your way across, and that leaves us with 0.3212. So this area here is not what we're looking for. not between the mean and the standard, and the z-score. We want to know above that. So remember it's 0.5 above the mean because it's half the data. So what we need to know is the probability that z is greater than 0.92 is equal to 0.5 take away 0.3212, which is equal to 0.1788. So that must mean that that area is equal to 0.1788. So the last thing we need to do is write our answer in context. So that leaves us with the probability that a shark has a length greater than 10.96 is 0.1788 or 17.88%. All right, so that's it. Go back through that if you need to, but the actual procedure is exactly the same. What's different is recognizing that we have to take away from 0.5. So just to summarize again what the steps are: draw the picture, calculate the z-score, look at the probability table, and write your answer in there. So write the probability by going 0.5, take away whatever the probability is, or whatever you get from the table. So that's the end of the lesson. So for today's lesson, there is some questions in the textbook, in the workbook. There's also a worksheet. So do the first page first, and then to follow the worksheet. So then do the worksheet. Then to follow that, go back to the workbook where there's another page, which is a mixture of the 3 previous lessons. So looking at between the mean and a score, looking at being less than a value to the right of the mean, and then today's one looking at the right tail. Hopefully mixing it up doesn't cause you too many problems. If you're stuck, go back to the individual lessons to look to see how to do them.